Okay, so we'll be starting with the first question. We'll quickly discuss the first question. Let me share my screen. Enter screen. Is my screen visible to all? You can just like unmute or write it in the chat, something like that. Okay. So the first question says that Tyro and Dom are fighting over who makes the first problem of the contest. Both of them are very lazy, so they don't want to make it. Tyro has a patience level of A, and meaning he'll be convinced on the eighth time when Dom asks him to make the problem. Dom, on the other hand, has decided to convince Tyro at most B times. If Tyro is not convinced by the Bth time, Dom will proceed to make it himself. So, given the values of A and B, who will make up the problem? So, pretty simple, I think. Just have to take inputs. See in. Okay. This is, I don't think there will be much doubt. So what was it? If A is then equal to B, we'll output Tyro, I think, right? Dom. So basically in this question, what is happening is, Dom, can you see this part? I think OneNote part. Is it visible? So Dom has this much patience level. I think they gave it as an A, and Tyro has this many chances to convince him. So basically, you have to check if he can convince him. 1 second. Okay, yeah, simple. Uh, if he can convince him in this many attempts, A greater than equal to B, we'll just write Tyro or Dom, whatever it was, and we'll just submit it. So A greater than B. Okay, yeah, sure. Run. Let's see. Yeah, see. So, did anyone have any doubt in this question? Like, what is happening? I'll just draw a quick, like you guys will understand, right? Suppose like he will listen after, let's say, 5 attempts, and Tyro, he will just try, let's say, 4 times. So who will do the work? He will do the work because 4 is less than 5. Makes sense? This is pretty much the logic of this part. So we'll continue to the next question. What is the next question? We have even some summary. How many of you did someone get stuck in this question? Like, did you face any difficulty in this question? I'll quickly read it. So what they've asked is you have been provided with an array A. You have to find the size of the largest subarray of A, which has an even sum. So you have to find the largest subarray which has an even sum. Okay. So what can we do? For example, this is the array. What will be the largest subarray you can get? For 2, 1, 2, let's see. If you go for 2, it's fine. It is even. You add 1, it is odd. Yeah, so you get to 2, 1, 2. You go to 2, you go to 1, you will find it's false. This isn't true. And you go here, it is still false. So the largest you can get is either this one or this one. So the answer is 1, as you can see here. Yeah, first one. Then what about 132? 132, the whole array you will get, the maximum length is 3. Like you can take the whole array. So your answer is 3. What about 22112? 22112. So what is the overall sum of this? This is odd, right? No doubts regarding that, I hope. Is this clear? Like you guys can understand what I'm writing, right? Like I'm using a mouse, so if it's not clear, you can tell me. I'll just like type it or something. Okay. Am I audible to everyone?
Yes, Bhaiya.
Okay, sure. So yeah, what can you do here? So you start with 2, you find another 2, still even. Here you will find this is odd. Now if you add this, you will find this becomes even. Okay, this is fine, right? Then you add this odd, and again you add 2. So this becomes it. This remains odd. So this is the largest array that you can take. This much clear? What are the other possibilities? Like this is a subarray that is true. This one is true, and this one is true. These are true. So we have to find the largest one. The largest one is of size 4. So how can we find that? So like this is a pretty simple implementation. What you do, like this is the code. I'll just like take help from here only. As you can see, actually this you can brute force kind of. So your n is 50. So and what is the time complexity of this code? Can someone tell? If I have 2 for loops, they go to n. What is the time complexity? N square, yeah, n square. So yeah, this is an n square approach. But worst case scenario, my n is like 50. So this is like 50 square is 2500. So here you go. 2500, that pretty easily passes all your test cases. So what you'll do is you start from I equal to 0, and you go and like you have to check a subarray, right? So suppose this is my subarray. I'll make it. What was it? 22112. 22112. Your I points to this. Okay. You can consider this as like the starting index of your potential subarray. And your J, what we do is J is your ending index. Okay. Uh, is this like understandable? Like what we are trying to do? So what we'll do is we take an I. From this I, we'll keep on moving this J. We'll move it here first. If it is even, we check if this is like the maximum length we have encountered yet. So what you'll do is you keep something like len or max length. I'll call it mlen. This is your final answer. This will be your final answer. Initialize it to 0. So first you'll see your I equal to 0 to 1, 0 to n, I mean. and you have your j equal to end of the array. So can anyone tell why I'm using I instead of I plus 1? Any reason why we are using I instead of I plus 1? You can write it in the chat box, that is fine, you know. So like it is kind of interactive. We'll also know if you're understanding. Okay. Okay, so like since no one is replying, I'll just assume you guys will understand this part. So this we are starting from I because this one block itself is also a potential candidate as an answer, right? That is clear, right? So what we'll do is we start from here, we move our j, we'll find this. My current sum,
Yeah,
like
can
the
you
sum.
maybe explain this part again? Means the block one part.
Okay, so what happens is if your I is 0, your j, it also starts with from 0. Why are we taking this? So if we take 2, is 2 a subarray and it is even, so can it be an answer? ये वाला part मतलब like answer हो सकता है क्या? Only 2.
Yes, if the rest of the arrays, rest of the sub arrays are not bigger than two.
Yeah, but that is a different case. I'm asking if like you start with something. If I start with some I, suppose let's say
Okay, so we have to check the first element also. So that's why we're starting with from
we
starting
start
zero with
from,
zero.
yeah, this is actually like a brute force approach, right? As I said, like you take two loops of
Okay, okay.
and for loop. Okay, so you take this. So this is your subarray of length 1. Then you add this to your current sum. Like initially your current sum was 0, then it became 2. Then you added another 2, it becomes 4. So what is your current max length? How can we determine this? 2, 2, 1, 1. Yeah. So suppose I is your starting index, right? And till my j has moved till here, j equals to 1. So j equals to 1. So what is the length of my subarray? Current maximum length. Can anyone tell?
J plus one.
Yeah, j plus 1, or you can actually, you will observe it is j minus I plus 1.
Yes, yes, yes.
Yeah. So this much is fine, j minus I plus 1. This will be your length. Okay, you maintain this as your length. So I'll move here. This is my, what will you say? This makes my current answers false, like current becomes odd. I'll not update my answer, okay? Because this is not a potential answer, right? So it will still remain like I'll maintain the length equals to max and j minus I plus 1. Okay. So length, this will be like your condition. And when will we apply this basically is till here, what is my maximum answer? It is 2, right? Length of my maximum subarray. Then we'll add this. Again, my sum, what will it become? It will become 6. Is it even? Yes, right.
Yes, yeah.
Yeah. But what is now your value of j? This pointer, what is this index?
Index
third index, right? And my I is still 0. Okay. So what will be the answer? 3 minus 0 plus 1. So my current answer is equals to 4. As we've seen the test case, you will notice that this is the maximum answer, and we've discussed this. Like, this makes it odd again, and this still remains odd. So till the end of the array, your maximum answer has remained this. Now what we'll do, since our in this loop ended like this one, this loop first iteration done. So this I will move now, I plus plus. So this will move to here. So I becomes 1. And then you do all the steps again, but for like a smaller array. And then you will check if this is true, and like that you will finally get your answer. And we have implemented it here. As you can see, I've taken my test cases as input, while t minus minus, I have taken the length of the array. This is, you can like declare an array as well, like you will just like int a of n, something like this. And then you take your input, and this will be your max length. Now what we'll do, we maintain this cur, like cur is like my current sum. So I'll keep moving this. Here you will find I have added this. If I find this is even, I'll update my max length. Otherwise, I won't do anything. Finally, you will have this max length. Since you have checked all the possible subarrays, that will be like your final answer. We'll now submit this. Okay, yeah. So implementation is clear. Like how many of you guys are confused? If the sum is even. Yeah, you can also do that. Otherwise, we take 1 second. Otherwise, we take the first and the last indices of odd values. Then we make 4 subarrays from both sides of both indices. Okay, first part is fine. Otherwise, we take the first and last indices of odd values. Then we make 4 subarrays from both sides. Okay. And like you want to split it, right? Like your I will be something like this one. So you will have something like this. You found your odd from here, from the opposite side, and you have found your even from here. So this part will be even, you are saying. This part will be even. Okay, yeah. Then we separate from both sides of both the indices and print the size. Yeah, you can do that as well. Like that's not an issue. This is like a brute force approach, right? You can optimize it. Did you like implement this code, like this logic, while you were giving the contest? Okay, it passed, right? Okay, yeah. So basically, we are checking all the possibilities because our constraint is small, as you can like see here. This is just like 50. So 50 easily passes. We don't have to worry about anything. But still, yeah, this is like an optimized approach. You just find different ranges. Okay, then we'll come to the third question. Yeah. So what was the third question? Okay, this one was actually pretty easy if you guys actually, observe it. They basically gave you all the answer in the test cases. So what happens is you have been provided with a 2D grid, and you are given 4 binary strings of length 4, where S1 refers. So basically, your string will look like something like this. Your S will look like left, right, I think up and down, right? Up and down, yeah, up, down, and you have some grid, 2D grid. Yeah, exactly. Like this is actually they just gave you the answer. You'll have to notice something. Okay. Uh, here, actually, even I made that mistake. What happens is you will notice that for, let's say, if your count is one, basically something like this, 0010. If you get even one count, so what will happen if you move in any direction? And you have to like stay in this 10 minus 10. This is like your limit, and you start from 00 origin. Okay, 10 minus 10 minus 10. So if you can move only in one direction, what are your possibilities? If you can only move down, how many points can you visit? Can someone tell? Like others also answer. Saw one person answering. Yeah, he answered only. But like, like what is happening is this is your 0 to 10, that are 10 points, but you also have to include 0. So plus 1, that is 11. Can someone tell what happens if you are allowed to move like in two directions, like two opposite directions rather, like up and down, right and left? How many possibilities are there? Yeah, 20 points and like 0. You can move 10 points here, 10 points here, and 0, same here. Okay. So what will happen if your string is something like this, 1100? You will get 21. And if you have the opposite string, 0011, you will again get 21. Now, this actually seems very simple, right? But you will actually find one case that is 1010. L R up down. Yeah. L. Okay, so what will happen is you can move in, suppose, this coordinate only. You can either move up and left. This is like your area where you can potentially move. Can everyone imagine this? Like this is your 2D area and this is the place you can move in. So like they gave us the answer actually. How many possibilities are there? No, that this one. What happens in cases like these? If you have like 90-degree difference, 0110. So what is this? Right and up. So basically this area, right? You can move 11. You can consider this like 11 square, 121. Like you have 10 points here. You guys understand, right? 121. Why? You'll like this is simple maths kind of. You'll get 121 of these. And what you'll find is there are basically two cases. If your uh, these ones are in 90-degree, like not in the same sense, they have like a 90-degree difference. What you will do is you will have 121 possible moves. But if they are in the same sense, that is 1100, your number of moves are like restricted, 21. Is this part clear? Like this is your main catch. Basically because they have provided you all these cases. Do you think there will be any difference if you have 0111? Yeah. Zero, like they give you the answer. You don't have to calculate it yourself. But do you think there will be a difference if you have a string 0111? we can also do that, but yeah, like there are multiple possibilities, as Bhaiya also said, that there are multiple possibilities of how you can solve this, but you don't have to do much in this question as well. You take your string as input, you count your number of ones. If it is zero, there will be only one possibility, that is one. You will stay at 0, 0. If your count is 1, as they have said, 11, you can only move in one direction, either left, either up, right, or down. If you have two, there you have to check if any of these strings are your values, because this is like 90-degree difference, as you can see. So you'll get 121. Otherwise, same direction, you'll get answer as 21. Okay, and for 3, they have already said 231, and for 4, 441. So I hope it's clear to everyone. Like you just have to pick this pattern, nothing else. So we'll just submit this. Yeah, see. So how many of you guys got this one right? This was number 3 in the 4. Was there anyone who was not able to solve number 3? Okay, like is this partly like where were you getting stuck? Can you tell?
Yes, we I got it. Actually, I solved the first two questions and went to the X or sum. I
Oh,
find it too long, so I skipped it and went to the X or sum.
okay, okay, fine. That is fine. But yeah, like this was simple observation. You can do it. This is practically like. Do you guys think there is some n complexity, or it is like some other complexity? Because you don't have to do anything else. So this is pretty much constant time, right? You're only running this loop to count your number of ones. And you like this is all four like four operations. It is done. Everything if else constant time. You don't have to do anything. So this part is done, I think. Now we can move to this question, fourth question. So yeah, this I think a lot of people got stuck in. So, okay, what can we do? Int as pseudo-minus. Can you explain your logic for acha, you made a formula for that, right? Something like that. Okay, like you can did you try and implement this? Like, did you run it? Okay, yeah, check it. If it doesn't work, we'll find out why. Okay. So yeah, now the fourth question, I think most of you got stuck in. I'll close this. Yeah, so what they've asked is, yeah, so try this out. Everyone, try this part out, and you can like tell us if it went correctly. So in this problem, what you will see is you have a binary string, right? And you have to find, like, they have provided this definition of a mode. So let's see what is a mode. Suppose you have 110 101, something like this. So what will happen is this is a substring. The mode is like the max frequency element, number of max frequency elements. So here only there is one element. So what do you think? How many? So it will be one, right? What about this substring? Both of them are 1, 1, right? Both have the same frequency, so we can say for your L equals to 1 and R equals to 2, you will get 2. So we have been provided this function f of LR and your double summation L equals, what they have provided? One second. Yeah, actually R equals to L to N, and from L is equals to 1 to N. We are basically checking all the possible substrings here. If that part is clear. Like we are being provided with a string, and we'll check what is like the score total, like the final answer for this one for all the possible substrings. So what will happen is you go here, you'll go here. For this substring, you'll have one. For this, you like Acha, how many? One thing that you'll notice is at the most basic case, you'll have at least answer equals to number of substrings. Like if all these are just ones or just zeros, what do you think will the score be? And why do you think that it will be n into n plus 1 by 2? This is not related exactly to the question. You can like observe and tell why it is n into n plus 1 by 2. Okay, like what will happen is consider this. You will take a substring of length. Let's number of substrings. How many substrings of length 1? Can you tell something like this? What will basically happen is you take the whole string. So this is one string. If you break it, you'll have like 2 plus 3. And like this, you'll have a total of n substrings when all of these are like individual. Okay. So the answer to that is basically n into n plus 1 by 2. Does everyone agree with this part? That if I take this, I take this, I take this like that, I'll get this as the total number of substrings. Like if you guys agree, you can like raise your hand or something. So we'll also know. Okay, so what about others? Is it clear to you? Yeah, so everyone clear with that, right? Okay, okay. So now what we are trying to do is we'll take our inputs, uh, but like, can you tell me what is the maximum value this function can have? What are like this function will always have two values. Yeah, it can be either two when both of them have the same frequency or one when they have different frequencies. Okay. So when it comes to frequencies, what do you guys think? What is like a word that comes to your mind? Like it is used very frequently in a lot of contests you guys might have given. Yeah, count also. Like there is this concept that we like it's how many of you guys know about hashing? Hashing, I think most of you know, right? Is there anyone who does not know hashing? Okay, yeah, it was also done in the class. So basically in hashing, what we'll do is we'll store the frequency of one and we'll store the frequency of our zeros. And yeah, so actually let's store the difference of these two. Okay, like what is the difference of the frequency of these two? So what we'll do is you run a loop for your string. Uh, your I is equals to, let's say 0 to n, n minus 1 rather. Okay, so what we'll do is we keep a counter for uh, 0. Let's say C0 equals to 0, uh, and C1 equals to 0. And we'll store the differences of their frequencies. So we can find out if this like frequency difference has been encountered or not. Okay, yeah. So what you'll do is simply you maintain a map. Like in C++, we have two options, unordered map and map. I will use an unordered map. Okay, like this is like a map, and a map has key value pairs. So it will be something like, I'll just show you guys this part. Yeah, this is how we declare it. So what does a map have? A map has like a key, and it has a value. One second, just a second. Uh, so what we'll do is we'll store the difference between our frequency of 0 and the frequency of 1. As we have already seen, like if the difference is not 0, like the difference between the frequencies is not 0, you will have uh, 2 as your answer, otherwise it will be 1. So what we'll do is you run a loop. If it's like if your string is 0, if you encounter a 0, you will increment your C0 plus plus, and you'll do the same for uh, if you encounter a 1. Okay, and then you'll check. You will have this variable difference, which will be basically C0 minus C1. Now is like your main observation. As like the main observation was always that your this part, it will be either be 1 or it will be 2. So what will happen is you will check if this difference is present in my map. So how do we implement this in C++? I'll show you the syntax. If this key is present in my map, hmm, as you can see, we have this find operation. This will tell you if you apply this condition, that means I went through whole of my map. I went through my map and I didn't find it. So I've reached the end of my map. So if you didn't find this particular difference, what we'll do is we'll say, okay, I've encountered this difference once. I hadn't found it before, so I'll just make this key value pair. Your frequency of this particular difference is mapped here. If the difference already exists, what we'll do is we are trying to calculate our answer. As we said that in the simplest scenario, where was it? If all of them are 1, your answer will be at least n into n plus 1 by 2, right? So this is like total number of substrings that we have. And if we find it, we'll just simply add, if we found this difference, we'll add the substrings which had this difference, number of substrings which had this difference. And then we'll increment our difference again. So like you'll find that, okay, there was a substring which had, suppose, 1 as a difference. Again, I found a difference of 1. That means this substring also will have that. So you'll have something like 2. Okay. After that, yeah, so basically this much is your code. What your main observation was this fact that your f can either have value 2 or it can have value 1. If it is 1, I'll add it. One more thing that while implementing is you have to initialize this part. What does this mean? Can anyone tell? What does like map of 0 equals to 1 mean? Yeah, but like why are we specifying 0 to 1? Like if you find the difference is 0 by 1. Like if you don't take any character, like your empty substring, it has the same frequency, right? And the difference is 0. So the difference of 0, you initialize it with 1 and then you like run it. Okay. So whenever you encounter a 0, it basically means you have found a substring which has same frequency. This. Then that also means that this is also true, right? So we'll add whenever we encountered this. So basically this was your implementation. You add this part and then you increment this and your final answer is this. This is like, so how many of you guys didn't understand this part? Like, can repeat again. Or if someone had some other approach, that also you can tell us. Achha, how many of you guys attempted this question? Like you went through it and you were like, okay, I can try this. But like, yeah, okay. One person did it. What about others? Okay, two people tried it. Okay, that's fine. Like, um, what was your approach? Couldn't implement. Okay, yeah, like this part was bit like that. TLE, like how did you apply it? Can you like share your code or like your approach? You can just type it or like something like that. Okay. Oh, so you made those sub-arrays, right? So it went to n square. Let me see what was your constraint. Yeah, n square will cross it, right? It becomes 10 to the power 10. Yeah, that is fine. You thought of the hashing method. Like whenever you see something like this, you have to like check the frequency. You initially think hashing. Okay, yeah. Like even if you make for n into n plus 1 by 2 subarrays, that is like n square already. So the overhead is still going to make it cross, right? Yeah, that won't pass. That won't pass. Actually, for like the next question, like I'll just tell you guys, like if you notice now, it's just like a formula you have to implement. It will be like one thing you'll notice, right? That for one, like if you're, I mean, like those who have not gone through this question, go through it. What you'll find is for like k equal to one, there will be n factorial ones, and then you'll have to check for there will be something that involves factorial calculation. So like I hope you guys do one thing, right? There is something we call pre-computation. So like it doesn't get involved in your test cases. What you do is before your while t minus minus, just compute your factorials of any function you want in an array, and then you just access it in constant time. Okay, so that reduces your time complexity overall. Go through this question. This is like very mathematical. You'll have to find some observations and you'll get your answer. Okay, like like the test cases are like pretty clear. Is there anyone who doesn't understand that question? We can like discuss that. Shaunak, yeah, Shaunak, do you have any doubt regarding this question? Which one? This one? Fifth one? Uh, Max Kesabari. Yeah, like that is fine. You like try it again. You can go through the editorials or something. Like this is you'll have to sit and write a formula. You'll click okay, and like after that if you don't if you yeah you notice the factorials, right? So for factorial you can like simplify the calculation by pre-computing all your factorial values, and after that if you don't find the formula, tell in the group. We'll like show it how you got the answer. Okay. NCR, I don't think it will be NCR actually. NCR, you'll have to have like an inverse. What was it? In MMI, you have to check like a multiplicative modular inverse. That is like you won't need that. You can solve it using normal factorial and multiplication. Like I understand why you will say NCR, but like NCR will become very complicated. You can implement it, I think, but like if you solve using MMI, it will be if you are calculating factorial, factorial is fine. MMI is a bit more complicated. Don't have to go till that. Just yeah, there is something called multiplicative modular inverse. Like what happens, right? If you write NCR, you will have n factorial by r factorial. So dividing by that is not preferred, right? So what we'll do is we'll find this r inverse factorial. And since whenever you have questions related to factorials, generally you are provided with something like this. You can like have to divide by this. Okay. 1e9 plus 7. So you get some answer that is in your long range. So for that, there is this. Let me share it. I think I have the CP algorithms. Yeah, this one. We'll also like share it in your resources. We'll provide the resources so you don't worry about this, but this won't be required. This is like something extra if you want to know about. Okay. Ah, it's fine. Like, but yeah, you only need factorial for it. You don't need this part. Like NCR calculation, that will take a lot of time and you'll get maybe wrong answers as well. So everyone try this part. Okay. You will like get this formula. If And if you don't get the formula, we'll discuss it in the group. Okay. Like all the questions are clear till this point to everyone, right? I think. Or like if you guys have any doubt, like in the previous questions as well, we can like discuss. If you guys have any other questions, you can ask us. Otherwise, like we'll end the meet for today. Yeah, I'll share the code of question number 4. Like we'll provide the resources and that you'll get the solution for question number 4. Okay. We'll share the recording as well, so don't worry about that.